In this video, we'll continue looking at some simpler sorting algorithms. Specifically in this video, we'll talk about insertion sort and bubble sort. So first, we'll take a look at insertion sort. Now, insertion sort works by iterating through the array, and as you come to each index, you'll see a new element, and then you put that element in the correct location that it should be among the previous elements you've seen. So you're basically keeping a sorted subarray at the beginning of the array of the elements you've seen so far. So trivially, your first element is a sorted subarray, but then you'll see the second element, which is 2, and so you'll swap those elements, so now you have 2 and 9. Then you encounter 6, 6 would go in between the 6 and 9, then you encounter 7, 7 would go after 6 but before 9. Now 1 is the smallest element, so then you would put it at the beginning, then you encounter 5, you put it in its correct location, and then finally you reach 3, you put it in its correct location, and then now you have a sorted array. So notice, as you move through the array, you're sorting a bigger and bigger chunk of the array. So in our implementation, we're going to have start and end to indicate where the bounds are that we're sorting between. Then we're going to have a current index. That's going to be the index of the last element in that sorted subarray. Now, as you move through the array, you'll notice that current moves as well. And then as you encounter a new element, you need a way to figure out where it goes. So we're going to have a position index that we're going to use to look for the correct index of that newly encountered element. And so, for example, position will move toward the beginning of the array. We'll compare the two elements, and we'll notice 9 and 1 are out of order, so we'll swap them. Then position moves closer to the beginning. Again, they're out of order, so we'll swap them. And we continue that until we reach the beginning of the array. So now let's take a look at that in code. So just like with all of our other sorting algorithms, we're going to start off with a method that takes just an array as a parameter, and then it's going to call the helper method that'll take the array and the indices, which initially will be 0 and the last element of the array, which is length -1. Now our actual helper method will have two parameters for the min and max index that we're going to sort between. Again, this is to allow us to sort a part of the array when we need to do that. Just to make sure we don't have any problems with the array indices, we're going to normalize those to make sure that we don't start before index 0 and we don't end after the last index in the array, and that we don't end after the last valid index in the array. Okay, so here we actually will start in on the algorithm. We'll have a for loop, and our current pointer will start it at the beginning of the array, and it'll go all the way to the end, and we'll increment it each time. And remember that the current index is essentially the length of the sorted sublist that we have at the beginning of the array. So now we want to keep track of the index of where we're going to insert that newly encountered element. And then we need to shift the larger elements to the right. We're going to use a while loop to do this because we're only going to do it while we're not at the beginning of the array and while the previous element is larger than the one we're looking at. And if that's the case, we'll swap those and we'll decrement the position index. And that concludes our algorithm, other than a typo. So let's test this. So here, remember, we have our tester. We're going to test insertion sort 500 times, generate a random array and sort it, and then verify that it is actually sorted. And then when we run this, we can see that it does indeed sort the arrays. So the last of the simple sorts we're going to see is bubble sort. And bubble sort is probably the sorting algorithm that you would come up with if you were trying to come up with one from scratch. So bubble sort works by iterating through an array, and it swaps neighboring elements that are out of order. Then we repeat this until we don't need to do any swaps. So we're going to have our start and end indices of the array that we're going to sort. Then our position index is going to be what we're going to swap until. And if you think about it, as you're swapping elements that are out of order, each time you scan through the array, the largest element is going to be moved to the top. So once we scan through the entire array, next time we can actually move that position index in one. And we'll see how we do that when we see the implementation. We'll also have a scan index, and that'll be the one we're keeping track of what we're looking at in this iteration, and we'll compare the two indices adjacent to scan. So as the scan moves through the array, it'll see that here's two things that are out of order. So it'll swap them and then continue on until we get to the end. And notice that 9 is now at the end of the array because it was the largest element. So we kept swapping it because it was always out of order until it was at the very end. Now, since that's in that last available spot, we know that there's no reason to check that anymore. So we'll move position in by 1 and start the scan all over. So like the source we've seen before, we're going to start off by creating a bubble sort method that takes an array of comparable objects as its parameter, and then it's going to call a helper method that passes that array through and then gives the index 0 to length -1 so that it sorts the entire array. Again, that's to allow us to have this helper method that has additional parameters for the min and max index that we want to sort between, which will allow us some flexibility on using these same methods to sort part of the array. So we're going to have an embedded loop, just like with the other simple inefficient sorts. The outer loop will be for the position variable, which will keep track of the last index that we need to check in that iteration. So we'll start at the end and move that in as the higher values get moved to the end of the array. And we'll decrement position since we're moving it toward the beginning. Then our inner loop will be the scan variable that we'll use to keep track of where we are in that iteration. And we'll increment that one. As we move through the array, we're going to compare the adjacent elements, and we'll swap them if they're out of order. And that completes our bubble sort method. Let's open up our sorting tester and verify that that does work. So we're going to say that our sort type is bubble sort, and we'll call bubble sort 500 times, just like we've done in the past, and we'll notice that that does work. So this completes our walk through some of the simple but less efficient sorts. And then, as you can see from the sort type enum we have, we're going to start talking about the more efficient sorts next, merge sort and quick sort.